Hello, boys and girls of St. Lucie Public Schools. I am Miss Owens, the math coach at Longwood Elementary, and I am excited to work with you guys, so thank you for tuning in with me. In today's lesson, we are going to work on representing fractions that are greater than 1. So what is a fraction that's greater than 1? A fraction that is greater than 1 is a fraction that's greater than 1 whole. Let me give you guys a better example of understanding fractions that are greater than 1. Let's say you have 3 sandwiches. That you want to share evenly between yourself and a friend. 3 sandwiches, but there's 2 of you. So what would be the correct way to share 3 sandwiches with the 2 people? How much of the sandwich would each friend get? Let's take a look at that. You can give this sandwich to one friend, and you could give that sandwich to the other friend. But what exactly do you do with this middle sandwich? So if you suggested cutting this sandwich in half, that's a really good way to look at it. So each friend would get 1.5 sandwich, correct? So each friend could get 1.5. Okay? Now, another way that you could look at it is you can take all 3 sandwiches and cut them in half. How many halves would you have if you cut all 3 sandwiches in half? Good job. You would have 6 halves. How do you share 6 halves with 2 people? Awesome. Each friend would get 3 of the halves. So this friend would get these 3 halves, and then this friend would get these 3 halves. So let's go back and take a look at the way let's take a look at how we can write that using fractions and mixed numbers. So we'll take the 3 sandwiches, and each friend would either get 1.5, or each friend would get 3 halves. So let's go ahead and move on to our vocabulary. Now at this time, if you haven't gathered your materials, go ahead and get something to write on, get your Workspace book, and turn to the pages where you have your vocabulary writing space. You want to record some definitions. So the first word that we want to take a look at is a mixed number. So go ahead and write that down. Mixed number. And the example of the mixed number that we just worked on would be the 1.5 sandwich that the 2 friends would get. The reason why it's called a mixed number is because it has a whole number and a fraction in it. Now, there are some vocabulary words that we're going to add in right after our next one, which are long overdue. So just keep following along with me. The other word that we're going to log down is improper. Fraction. And the improper fraction that we use in our example is the 3 halves. And the reason why it is an improper fraction is because 1, it's greater than 1. If you give a friend 3 halves of a sandwich, Well, that friend can take 2 of those halves and put it back together and make 1 whole sandwich. So 3 halves is the same thing as 1 whole and 1/2 piece. So the first thing that we need to understand about improper fractions is that they are greater than 1. The other thing that we need to understand about improper fractions is that when you take a look at an improper fraction, the top part of the fraction, also called the numerator, is greater than the bottom part of the fraction, which is also called the denominator. And those are the very next 2 words that we want to add to our vocabulary list. Those are the 2 words that I said it's long overdue. We have been using upper part or top part of the fraction and bottom part of the fraction long enough. So with this one, we're going to make an illustration. So let's take the fraction 3 halves, and we are going to draw and label using arrows to name the different parts of this fraction. So the top part of the fraction is called a numerator. And then the bottom part of the fraction is called the denominator. And then the bar in the middle part of the fraction that separates the numerator from the denominator is called your fraction bar. Okay, go ahead and log those vocabulary words down and also draw the illustrations to go with it. And then when you're done, you can look in the glossary in your Workspace workbook. And I want you guys to read up on those definitions to give your memory some more power. Okay, so let's move into our fraction strips. So if you haven't noticed, by now, I have 2 sets of fraction strips here. Because in order for us to work with fractions that are greater than 1, I need enough tiles to make that, to demonstrate more than 1. Okay, so let's revisit the 3 halves. So, we had a sandwich with 3 sandwiches. Whoops. And we broke those sandwiches in half, and each friend gets 1.5. We know that this 1 whole is also equivalent to 2 half pieces. So again, the friend gets 1 whole and a half of the other sandwich, or the friend gets 3 halves. Each friend gets 3 halves. And that brings me into today's lesson. We're going to continue to work with representing fractions that are greater than 1. We will represent those fractions using a mixed number as well as an improper improper fraction. So let's move into a little bit more practice. So we're going to play a game called Roll 5. And with this game, you will need a dice. And you will roll the dice 5 times. You're going to use the tiles to build a train based on the fractions that you roll. So if I roll 1/16, I'm going to use a 1/16 piece. And then if I roll 1/4, I will use 1/4 piece. And I will continue to add those pieces 5 rolls to create a 5 section train. Okay? So let's say I rolled the dice 5 times. and I rolled a half, a fourth, another fourth, an eighth. Let's get my train together. And another fourth. What is this equivalent to? How many wholes, or which improper fraction, and which mixed number is this equivalent to? I don't know yet. Let's write the equation. So we have 1/2 plus 1/4 plus another 1/4 plus 1/8 plus another 1/4. Together, these fractions are equivalent to, let's find out. So we're going to use eighths to find out how many eighths do we need to match the length of this train. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8, 9/8, 10/8, 11/8. So 1/2 plus 1/4 plus another 1/4 plus 1/8 plus 1/4 is equivalent to 11/8. And if you look at the fraction 11/8, you'll notice that the numerator, or the top part of the fraction, is greater than the bottom part, or is greater than the denominator in this fraction. And once again, 11/8 is what we call an improper fraction. Now, how many wholes is in 11/8? Maybe so. We're going to use our whole strip to measure how many wholes is in 1/8 and how many fractional pieces will be left over. And we'll use this to help us create a mixed number. So I'm going to decompose 11/8. I notice that 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8 is equivalent to the whole. So 11/8, 8 of those eighths is equivalent to 1 whole. And then I have 1/8, 2/8, 3/8 left. So 11/8 is made up of 8/8 and 3/8. And those 8/8 is equivalent to 1 whole. So 1/2 plus 1/4 plus 1/4 plus 1/8 plus 1/4 is equivalent to 11/8. And it is also equivalent to 1 whole and 3/8. So let's review what we just did. We found a way to use eighths to figure out the sum of these fractions. And we represented that sum as an improper fraction and a mixed number. Well, let's try this with 16ths. 1/2 plus 1/4 plus another 1/4 plus 1/8. Let's write that down. We're running out of space, but I know we can find some space for it. So we have 1/2 plus, and boys and girls, I'm using the top fraction train, which is the one that we use in our roll 5. 1/2 plus 1/4 plus another 1/4 plus 1/8 plus 1/4 is equivalent to which total? So we use eighths to help us. Now we're going to use sixteenths. So I have 1/16, 2/16, 3/16, 4/16, 5/16, 6/16, 7/16, 8/16, 9/16, 10/16, 11/16, 12/16, 13/16, 14/16, 15/16. Let's just recount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16/16. Sorry. 17/16, 18/16, 19/16, 20/16, 21/16, 22/16. How many sixteenths did I use? 22/16. So 22 will go in my numerator, 16 will go in my denominator. Now, I am going to remove some of these eighths so we can figure out how many, well actually I'll put this back. How would we write 22/16 as an improper fraction? How can we find out how many wholes are in 22/16? Let's go ahead and cover up some of these to match the equivalency of a whole. So we covered up some of them. Drop this down just a little bit so we can see it a little bit more better. A little bit better. Let's see how many 16s are equivalent to one whole. 1/16, 2/16, 3/16, 4/16, 5/16, 6/16, 7/16, 8/16, 9/16, 10/16, 11/16, 12/16, 13/16, 14/16, 15/16, 16. So we have 22/16. Well, 16 of those 16ths is equivalent to one whole. So let's see how many other 16ths do we have left. 1/16, 2/16, 3, and I'm just counting these right here. 1/16, 2/16, 3/16, 4/16, 5/16, 6/16. Let me fix my brace. So I have 6/16. So 22/16 is made up of 16/16 and 6/16. Well, that's the same thing as one whole and 6/16. So the original fraction train, 1/2 plus 1/4 plus 1/4 plus 1/8 plus 1/4 is equivalent to 22/16, or it's equivalent to 1 and 6/16. Pretty simple when you're using the tiles. I know I have a lot of stuff up here, guys, but when in doubt, fraction strips out. Now, in these lessons, you guys are going to have to make more fraction tiles because you're going to need more in order to make more than one whole. So let's go ahead and we're going to talk a little bit more about roll 5. We're going to practice a little bit more with this. You guys can turn to page 19 in your Workspace workbook, and we're going to play a game of roll 5 using the problems on that page. Just need to clear out my workspace. I'm moving as much as I can. At this time, if you don't have all of your materials, you can gather them while I straighten up the board for the next activity. Okay. And you guys should be able to play roll 5 in your digital lessons. So I know you're probably like, Miss Owens, I don't have the dice. I don't have all of the materials for this activity. You guys should be able to play roll 5 and uncover and all of the other lessons that we're doing here in the digital lessons. Ms. Owens, why is it so important to have a clean workspace? Well, when you're dealing with fractions, you have to line things up evenly. If my workspace is crowded, it makes it a little bit more difficult to line things up evenly. So that's why I take as much time as I need. Okay, so let's say that I rolled, in my 5 rolls, I rolled 1/2, 1/4, another 1/2, and 2/8. Slide this over a little bit. Okay, so 1/2 plus 1/4 plus 1/2 plus 1/8 plus 1/8 is equivalent to, and we're going to use our fraction tiles to show all the different ways that we can represent the sum of these fractions. So I am going to write it more than once. And you guys need to write this down. We're going to write it down about 5 times, but for the sake of time, we'll get started with the first 3 times. 1/2 plus 1/4 plus 1/2 plus 1/8 plus 1/8 is equivalent to. So we're going to go ahead and see how many halves is equivalent to this fraction train. Okay, I'm out of a half strip. Oh, Miss Owens, how come you don't have another half strip? Let's see if I can get some of these to fill in for me. How many fourths would I need to match a half? 2/4. So I'm going to improvise and use 2 of these 4th strips to make up the missing half that I need. And we're going to pretend that that's a red half. So I have 1/2, 2/2, 3 halves. So 1/2 plus 1/4 plus 1/2 plus 1/8 plus 1/8 is equivalent to 3 halves. And I'm going to move this one back. And I'm going to fill in my half fraction here. So let's try it again using fourths. So we have 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. So this fraction train is also equivalent to 6/4. And again, we have more improper fractions. Let's try it again using eighths. How many eighths is equivalent to 1/2 plus 1/4 plus 1/2 plus 2 of these eighths? Let's add using eighths. It's 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 9/8, 10/8, 11/8, 12/8, 13/8. And we're going to try again using 16ths. 1/16, 2/16, 3/16, 4/16, 2, 4, 6/16. Add 2 more 16s is 6/16, 8/16. I'm counting by twos. 10/16. I'm moving 2 at a time. 12/16. 14/16, 16/16, 18/16, 20/16, 22/16, 23/16, 24/16. So let's go with the original train from roll 5. 1/2 plus 1/4 plus 1/2 plus 1/8 plus 1/8 is equivalent to 24/16. Now I want to know, what would this look like as a mixed number? So I'm going to use my 1 whole, and here is where the line stops, right here, my imaginary line. So everything on the right side of my imaginary line could be added on fractions to help me out with my mixed number. So if I look at the halves, that would be 1 whole and 1/2. So it's equivalent to 1 whole and 1/2. If I look at my fourths, 4 of my fourths is equivalent to the 1 whole, but I have 2 fourths left. So it's equivalent to 6/4 or 1 2/4. If I look at my eighths, 8 of my eighths is equivalent to this 1 whole. So I have 1, 2, 3, 4 eighths in addition to my 1 whole. So the original fraction is equivalent to 13/8. 1, 2, 3, 4. Wait, 1/8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, it's equivalent to 12/8 or 1 whole and 4/8. And last but not least, let's look at our 16ths. 1/2 plus 1/4 plus 1/2 plus 1/8 plus 1/8 is equivalent to 24/16, or it's equivalent to 1 and 1, 2, 3, 4, 5, 6, 7, 8, 8/16. And that, my friends, is how you represent fractions as an improper fraction or a mixed number. Without these fraction strips, it will be a little bit more challenging, but the goal in today's lesson is for you to be able to use fraction tiles to measure out a train to show fractions greater than 1. Keep practicing with those fraction strips. Thank you guys for tuning in, and I will see you next time.